Hi everyone, welcome to the Unit 4.3 quiz correction video. You need to make sure that you have your own sheet of paper out right now that you're going to be making your corrections to any problems you missed on this quiz. And then you'll staple it to the back of your review sheet and you'll turn it in along with your review sheet to get points back on your quiz when you take your test. Okay, so let's get started. On the first section, they ask you to express as a single logarithm and to reduce all fractions. So on problem 1, we're adding log base 3 of 81 plus log base 3 of 9. And since we're adding these two logarithms with the same base, we're going to multiply. So this turns into log base 3 of 81 times 9, or in other words, log base 3 of 729. Now, some of you went ahead and made this into 6, which is fine, but on your test, I'm looking for a single logarithm, so I want it to stay like this. You don't need to plug it into your calculator or anything. Just leave it as log base 3 of 729. On problem 3, we are subtracting two logarithms with the same base, so we go ahead and divide. Okay, so it becomes log base 3 of 108 divided by 4. And my final answer is log base 3 of 27. Alright, and now on number 6, we are adding two logarithms with the same base, so we multiply the numbers. So we're going to multiply. And it becomes log base 2 of 2 times 8. Or log base 2 of 16 is my final answer. And like I said, on these particular problems, you do not need to reduce to a number. Go ahead and just express it as a single logarithm and you're good to go. These are the answers that I'm looking for. I'm not looking for numeric values. Go ahead and make any corrections you need to that section and talk in your groups and help one another out for the next couple of seconds. Okay, on the second section, they're asking us to simplify each expression. And on number 7, we have log base 4 of 4 squared. Now, remember, if you have an exponent, you can bring it to the front. That's one of our log properties. If you have an exponent in your log, you can bring it out front. So this becomes 2 times log base 4 of 4. Now, we look at our logarithm in this problem, log base 4 of 4, and the way we figure out what that is equal to is we think, okay, what can I raise my base, what power can I raise my base to give me the larger number? So I can raise my base of 4 to the power of 1 to give me the larger number of 4. So this becomes 2 times 1, because 4 raised to the first power is 4. So 2 times 1 is equal to 2. So log base 4 of 4 squared is 2. Now the other way we looked at that problem was if the base is matched, then we scratch. So here we had a base is matched, so we were left with the 2. Okay, now let's look at number 10. Here we have another exponent that we can bring out front. So this becomes 3 log base 2 of 16, or 3 times log base 2 of 16. And we have to think now, what power can I raise my base of 2 to give me 16? And the answer to that is 4. So log base 2 of 16 is 4. So 3 times 4 is 12. is my answer. Now, another way we looked at that, we could have written 16 as 2 raised to the 4th power. And that was up to the 3rd power. Now, the base, and so that could have been written as log base 2 of 2 to the 12th, because when you have a power raised to a power, you multiply. And here our bases match, so we scratched. And look what we were left with. We were left with 12 again. So either way, whatever way is comfortable for you, you can choose either method. Okay, on number 11, I told y'all if you have natural log or ln and e, they are opposite of one another. So if they're right next to one another, you get to scratch them. So we're going to scratch the ln and the e, and we were left with 10t. On number 12, we have e raised to the 6 times ln of t. So remember, 6 ln of t in the exponent, if we have, ln is a logarithm. And if we have our number out front, we know that it was an exponent before. So this becomes ln of t raised to the 6. So I'm going to rewrite this problem as e raised to the ln of t raised to the 6. Okay, and remember, if e and ln are right next to each other, they're inverses of one another. So they get scratched, and we were left with t raised to the 6. Okay, moving on to 16. They want us to evaluate. And on these evaluate problems, they're asking us to round to the nearest thousandth. And that's where many of you got a point or two taken off on your quiz because you didn't round properly. So on 16, all we have to do is go to our calculator and plug in log base 10 of 25. So I go to a calculator page and I hit Control and then the 10 raised to the X button or the log button, okay? And I type in base of 10 and it's of 25. So log base 10 of 25. I hit enter and my answer is 1.39794 and thousandths place is the 3rd decimal. So in order to determine if I need to round the 3rd decimal up or not, I have to look at the 4th. So here it's a 9 and it's larger than 5. So because it's larger than 5, I round my thousandths place up to 8. So my answer is 1.398. Okay, 17 is the same thing. We're just going to plug in log base 15 of 800. So I hit Control and then the log button, base 15, oops, of 800. Hit enter, and then I look to make sure I round properly to my thousandths place. So I look at the 4th number out and it's a 4, so it's less than 5. So I can leave my 3rd decimal place as an 8. I don't need to round it up. So my answer to number 17 is 2.468. Okay, on number 19, I need to type in ln of 78 on my calculator. So I hit Control, and then E to the X button is my ln. So make sure you realize that it's different than the log button. You can't just type in log. You have to use the ln button on these. So natural log of 78 is 4.35671. Now I have to round to the nearest thousandths. So I look at the 4th decimal place out and it's a 7. So that means I have to, because it's greater than 5, I have to bump my thousandths place up. So this now becomes 4.357 is my answer. Okay, y'all go ahead and talk in your groups for a second and make sure you write down any corrections from the last 2 sections I've done. I didn't pause in the last one, so I'm going to give you some time now to finish writing down any corrections you didn't get. Okay, let's move on to the next section. And I know on the screen right here, we've already renumbered the quiz. I remember there were 2 16s, 17s, and 19s. So the problems are the same, but we've changed the numbers already. So these are the problems that y'all had to do. In problem 24, we are subtracting two logarithms. Log of 20x minus log of 4 equals 2. And because we're subtracting them, we have to divide. So we are going to rewrite this, or simplify this, as log of 20x divided by 4 equals 2. And when we simplify that, it becomes log of 5x equals 2. Now remember, there is a 10 that is assumed to be there. If there's no base written, we assume the base is 10. And we're solving for x. And the way we have to solve for x is we have to get rid of this log. So we are going to switch from log to exponential. So in order to rewrite this logarithm as exponential, we start at our base, pick up the 2, and then go to 5x. So we can rewrite this as 10 squared equals 5x. Now 10 squared is 100. So 100 equals 5x. We divide both sides by 5. And 20 equals x, or x equals 20 in other words. So go ahead and take a second and write that down. Okay, now another thing we have to double check is when we start off in our problems, for example in problem 24, is when we start off with logarithms in our original problem. So here we had 2 logarithms. We have to check our answer to make sure that it isn't an extraneous solution. So if I were to go type this in, I'm going to go ahead and type this into my calculator to make sure nothing weird happens. Okay, on problem 24, they're asking us to solve for x and round to the nearest thousandth. And here we are subtracting 2 logarithms with the same base. So we're going to divide, just like we did in the very first section of our quiz. So we're going to rewrite this as log of 20x divided by 4 equals 2. Now this becomes log of 5x equals 2. And remember, if there's no base written on a logarithm, it is assumed to be 10. So our base here is 10. So then, in order to get rid of this log, remember we're wanting to solve for x, so we need to get rid of this logarithm. We need to switch to an exponential. So we start with our base, pick up our 2, and then go back to the 5x. So we write this as an exponential equation to be 10 squared equals 5x. So 100 equals 5x, and then we divide both sides by 5 to get the x by itself. So x equals 20. Now we need to remember and be careful to check our answers anytime we start with logarithms in our original problem. So in problem 24, we do have logarithms in our original problem. So I'm going to go ahead and go to my calculator and check my answer. And the way I do that is wherever I see x in my original problem, I'm going to put 20 in to make sure I get a valid answer. And we need to just make sure that it's not an extraneous solution. So I go to my calculator, I hit Control Log, and we have a base of 10, log base 10 of 20 times x, so we're going to put 20 times 20. We replaced x with 20, minus Control Log of base 10 of 4. And then I hit enter, And we did get the correct answer of 2, so we're going to assume our answer is valid. Okay, now let's go on to problem 17. We have log base 4 of 5x plus 1 equals log base 4 of 3x minus 1. So, when we have logarithms that have the same base set equal to one another, we can go ahead and drop them. So all this becomes is 5x plus 1 equals 3x minus 1. Then we need to get all of our x's on one side and all of our constants on the other. So I'm going to go ahead and subtract 3x from this side and this side. And when you end up doing that, you're left with 2x plus 1 equals negative 1. Now I'm going to go ahead and subtract 1 from both sides of the equation. And that is equal to 2x minus 2. Many of you put 0 right there on your quiz, or you assume that negative 1 minus 1 is 0, and that's technically negative 2. Then, after dividing both sides by 2, we end up with x is equal to negative 1, because negative 2 divided by 2 is negative 1. Now remember, we have to check our answers anytime we start with logarithms in our original problem. So I need to plug in negative 1 wherever I see x into each side of this equation to make sure that it's valid. So let's go ahead and go to our calculator, and I'm going to type in log base 4 of 5 times, now my x value we found was negative 1, so I'm going to replace it with negative 1. 5 times negative 1 plus 1. And when I hit enter to see if that's valid, something comes up. It says it's a non-real calculation. So we now know that x equals negative 1 is an extraneous solution. So my answer here is that there are no real solutions to this problem. So many of you did get the x equals negative 1 part, but forgot to go and check. Okay, now on problem 27, we have log base 5 of 9x plus 3 plus log base 5 of 2. And it's equal to log base 5 of 18. Now, some of you automatically wanted to scratch these log base 5s out, but you cannot do that quite yet. You need to go ahead and combine and simplify this side first. So because we're adding two logarithms with the same base, we multiply the larger numbers. So this is log base 5 of 9x plus 3 times 2 equals log base 5 of 18. And when we multiply 2 times 9x plus 3, we end up with log base 5 of 18x plus 6 equals log base 5 of 18. Okay, now we can cancel out these logs of 5s, log base 5s, and we end up with 18x plus 6 equals 18. To get x by itself, I subtract 6 from both sides, and I end up with 18x equals 12. Divide by 18, and x equals 12 over 18. Now that reduces down to 2/3. Okay, or in other words, or x equals 0.667, if you wanted to round to the nearest thousandth. So either one of these answers would be acceptable. The biggest mistake I saw was that y'all started scratching out the log base 5s, and then what you ended up doing was adding 2 to 9x plus 3, which was not the case. You need to multiply 9x plus 3 and 2, not add them together. So, once again, we had logs in our original problem, so let's go back and check our answers just to make sure it's valid. Remember, these are the same thing, one or the other, 2/3 or 0.667. So I'm going to go and plug in wherever I see x, I'm going to plug in 2/3. So in my calculator, I'm going to type in log base 5 of 9 times x, or 9 times 0.667 plus 3. And when I hit enter there, that gives me a valid number, and that's the only spot where I see x, so we're good to go. We can go ahead and accept 2/3 as our answer. Alright, let's move on to the word problems. Or actually, I'm going to give y'all a couple seconds to write this down, anything that you need to, and discuss in your groups. Take advantage of those in your groups that got these problems right that you missed. Okay, let's move on to the word problems that we did on the back. On problem 30, they are giving us a population problem. And in this section, they've given us 4 different equations up at the top that we need to use. On problem 30, they say the population of a meerkat community in Australia is declining at a rate of 6% per year. And the decline can be expressed by the exponential equation P equals C times 1 minus 6.06 raised to the T, where P is the population after 2 years and C is the current population. So it tells us the current population is 875. So C is equal to 875. And they want to know how many years it will be until the population will be 522. So we're going to replace P with 522. So I start off with my writing the original equation they give me down. I plug in 522 for P and 875 for C. I can simplify this to be 522 equals 875 times 0.94 raised to the T, because 1 minus 0.06 is 0.94. Now, I want to caution you, some of you were multiplying these two numbers together, which is not allowed because there's this exponent right here. So you may not multiply 875 times 0.94 yet. That's not allowed. So what I have to do to get T by itself, we want to solve for the number of years, correct? So T is the number of years. Is I'm going to have to take my equation and divide both sides by 875. Okay. And 522 divided by 875 is 0.59, sorry, not 4, 0.596571. And on this side of the equation, you're left with 0.94 T. Okay, so right now we have an exponential equation. And in order to solve an exponential equation, you have to switch into a logarithmic equation. So I'm going to start with my base of 0.94. Remember, that's the base of my exponential equation. You always start with your base, and we're going to log roll it. We're going to pick up the 0.596571 and then go back to the T. So I write this as log base 0.94 of 0.596571 equals T. Okay? And now I can go into my calculator and actually find this value. So that's all I need to do. I go to my calculator and I type in log base 0.94 of 0.596571. I hit enter, and my t value that they give me is 8.34834 years. So it's going to take 8.34834 years. But remember, they want our answer in the nearest years and months. Now, some of you took that as giving me this as 8 years and then also converting this number and multiplying it by 12 to give me the number of months. But that's not what they want. They want this to be converted to 8 years and so many months. So we have to look at this decimal part right here, this 0.3484, and convert that part into months. So we know that it's going to take 8 years plus so many months. And the way we find out that so many months is multiplying this 0.34834 by 12. So I go to my calculator and I type 0.34834 times 12. And when you enter that, you realize it takes around, that's about 4 months. So my answer is 8 years and 4 months to this problem. Okay, so go ahead and take a second, talk in your groups, write down anything you missed, and practice entering anything you need to in your calculator. Okay, problem 31. It says that Jared has decided to invest $5,600 at an annual rate of 8.23% at Capital One Bank. And part A asks us to write an equation that represents the money in Jared's account at time T. So I look back up at the top at the equations they've given me to find in this section. And we know that when someone's investing money and the bank gives you interest, and in this case it's 8.23% interest, that the money in the account is going to be increasing. So, and it doesn't say anywhere in here that they're compounding it, so we know that the formula that I'm going to use is A of t equals P of 1 plus R raised to the t, because that is our increasing exponential formula. And we're not dealing with compounding in this problem, so the formula within it is not necessary. So I'm going to write this as my initial amount that he's invested, P, is $5,600. The rate at which he's investing is 8.23%, but we convert that to a decimal to be 0.0823. Don't forget to convert a percentage to a decimal. We move the decimal place over 2 times. So this is A of t equals 5,600 times 1 plus 0.0823 raised to the t. And that is part A. That's the formula to represent the money in Jared's account at time t. Now in part B, they're asking us how long it would take for Jared to double his money in years and months. So if he invested originally $5,600, doubling that amount would be multiplying it by 2. And when you double 5,600, you end up with 11,200. So they want to know how long is it going to take Jared to get $11,200 in his bank account. So I'm going to plug that into the formula for the amount in his bank account, the A of T. And I'm going to set that equal to 5,600, the original formula that we have in part A. 5,600 times 1.0823. I just added together the 1 and the 0.0823 raised to the T. And now we're going to solve for T. So what we do to both sides is divide by 5,600 on both sides. And that cancels the 5,600 out on this right side of the equation. And 11,200 divided by 5,600 is 2. So we end up with 2 is equal to 1.0823 raised to the T. Now here we have an exponential equation, and we need to convert it to a logarithmic equation to solve for T. And the way I do that is I start with my base, which is 1.0823, pick up the 2, and then go back to the exponent T. So I'm going to write this as log base 1.0823 of 2 equals T. And I'm going to type this side, the left-hand side of my equation, into the calculator, and that will give me my T value. So I type in log base 1.0823 of 2, hit enter, and that gives me a T value of 8.76421. And I think they're asking us, no, that's fine. We're not rounding here. So it's 8.76421. My T value is 8.76421. But once again, they're wanting it in years and months. So I have to take the decimal part. We know it's going to be 8 years. But now I need to find out how many additional months into 8 years it's going to be. So I go to my calculator and I multiply 0.76421 by 12. I take the decimal portion and multiply it by 12, and you realize it's going to be about 9 months. So 8 years and 9 months is my answer. Okay? So take a moment, write that down, and make sure that you have corrected any problems that you need to on this quiz. The remainder of the class period, you can work on finishing up any of these problems on the review. Tomorrow, we should be playing a game, a review game, and you need to be making sure that you have this review done before you take your test on Wednesday. Okay? So, it's really important to me that you do these quiz corrections because I'm giving you an opportunity to earn some points back on your test. So take the time, finish your quiz corrections, and then you have the rest of the class period to work on any review problems. All right? Have a good one. I will see y'all tomorrow.